This is part 2 of section 1.4. We are continuing with some word problems. All right, a train leaves Dayton, Ohio, and travels north at 85 kilometers per hour. Another train leaves at the same time, traveling south at 95 kilometers per hour. How long will it take before they are 315 kilometers apart? Okay. This is the classic algebra word problem. Always involves trains. And these are the ones that have the worst reputation. You'll see them in comic strips. People make fun of train problems. But they really are among the easiest word problems we have. This is a distance problem. Distance problems always use the formula D equals RT. Distance equals rate times time. Okay? There are basically two types of distance problems. There's the type where two things go in opposite directions from each other, and then there's the type where two things go in the same direction. This, we have things going in opposite directions. When you have opposite directions, drawing a picture will usually help. So let's say this is Dayton. And we have one train that's going north, and we have another train that is going south. A drawn and labeled picture counts as organizing our information. Okay? The one traveling north is going 85 kilometers per hour. And the one going south is going 95 kilometers per hour. And we want to know how long it will take before their total distance is 315 kilometers. Okay. So what I need you to see here is that if I have a way of talking about this distance, and then a way of talking about this distance, I should be able to add those two distances together and get this distance. Okay? We know here they leave at the same time. So our time is the same for both values. So let's just say our t is the time traveled. Okay, so how far did this one go? Well, in this one, we do, all right, to find the distance, which is what we're really looking for, we do the rate times the time. The rate is 85, time is t, this distance is 85t. Very similarly, distance is rate times time. This is our rate. This is our time because they travel the same amount of time. This is 95t. And then what we said is if you add these two things back together, you should get 315. Okay, so if we combine like terms, 85 plus 95, we get 180. T is equal to 315. Divide both sides by 180. And we end up with T is equal to 1.75. These were in kilometers per hour. This is our time. We were asked to find how long it would take. So our answer is 1.75 hours. That's your answer. Okay, so let's look at the other type of word problem. Okay. Other type of distance word problem, I should say. All right, Sarah commutes to her office in Redwood City, California by train. When she walks to the train station, it takes her 40 minutes. When she rides her bike, it takes her 12 minutes. Her average walking speed is 7 miles per hour less than her average biking speed. Find the distance from Sarah's house to the train station. Now there is a whole lot going on here, okay? We know that we are starting from her house and we're going to the train station. So this distance should be the same no matter what, okay? And we're starting at her house every time and going to the train station every time. So we're traveling in the same distance and we're traveling in the same direction, okay? In this case, a picture doesn't help a whole lot. I mean, you can draw the picture, see that it's not helping much. We're going to go to a chart, okay? I'll be there in just a second. The other thing we have to notice, this is minutes, this is minutes, this is hours. We always have to make sure our units match. So before I go on, before I start doing calculations, I'm going to convert these. 40 minutes, that's 40 minutes out of 60 minutes. 40 over 60 reduces to 2/3. So 2/3 of an hour is 40 minutes. Okay, 12 minutes out of 60 minutes reduces to 1/5. So 1/5 of an hour is 12 minutes. So when I do my calculations, I'm going to need to use the fractions. Okay, so let's start organizing our information. If she walks, okay, the time it takes her, walking is 40 minutes. So it takes her 2/3 of an hour to walk, okay? When she rides her bike, it takes her 1/5 of an hour. Okay, I am using D equals RT still. Okay, now for her rate, we don't really know how fast she's going in either case, but we know that her walking speed is 7 less than her biking speed. So if her rate when she's biking is R, then she is R minus 7. 7 slower when she's walking. Okay. So now we have a way of talking about the time traveled and the rate. We need a way of talking about the distance, and we know the distances are the same. So if I can find a way of talking about the distance when she's walking, and also a way of talking about the distance when she's riding her bike, I should be able to set them equal and solve it. Okay? Distance equals rate times time. So rate times time. 2/3 times R minus 7. Rate times time, 1/5 R. These distances should be the same, so simply set them equal. And we need to solve this. So I have fractions. My least common denominator is 15. So I'm going to multiply both sides by 15 over 1. Now what happens is the 3 and the 15 reduce to a 5. So I have 5 times 2 times R minus 7. 5 times 2 is 10. And I'll distribute that in the next step. And this would be the 5 and the 15 reduced to a 3. 3 times 1 is just 3. So this is 3R. Okay, now let's distribute. To get 10R minus 70 is equal to 3R. Okay, now let's subtract 10R from both sides. Negative 70 is equal to negative 7R. Divide both sides by a negative 7. And we get 10 is equal to R. Okay, So what is it we found? We found R, which is how fast she rides her bike. We weren't asked to find how fast she rides her bike. We were asked to find the distance. So what I need to do is I need to take this and plug it into either here or here. I should get the same answer no matter what. So I'm going to plug in right here. 1/5 times R, 1/5 of 10 is 2. So the distance from her house to the train station is 2. This was in miles per hour, so this is miles.